start here connecting those equipments. The secret in this system, in this VICTRON system, is the administration of the DC current. The administration of the DC current coming from the batteries. Lithium batteries, AGM batteries, the batteries. That current, DC current, positive and negative, enter in those big positive bus bars. Yeah, I have a bar for positives and I have another bar for negatives, but those elements are intelligent. The first one that you found at the beginning is the shunt. We are going to connect two shunts in this system. In what situation I need a shunt? Why I need a shunt?
When you want to read
Because I want to read amps, basically, no? And temperature and volts, but basically amps. If I want to connect an amp meter, I need a shunt. We are going to connect in this project a couple of amp meters, and we are going to install a couple of shunts. One shunt per each amp meter. In this particular example, I have an amp meter analog, and other amp meter is digital, and one of those amp meter will be connected with this shunt. And the other amp meter, the main amp meter of the system, and the main display receive information basically because we are going to install at the beginning here a smart shunt. This shunt will be connected at the beginning. You see, guys? Let me explain how is the process to connect those devices. For example, I bought one additional amp meter, guys. One additional amp meter, that one, to read amps, voltage, and temperature of the batteries. And I installed this shunt exclusive for this amp meter. That's okay? Look at this shunt. I can enter here with the negative, and I continue with negative or positives. But normally in VICTRON system, they use the negative. They interrupt the negative. The big negative enter here, is interrupted, and the big negative continue here and goes over there. Okay, and here is the connection of this positive and negative directly here. And now I have the display reading amps and voltage and other parameters that I have in this display in this small circuit board. Everybody follow me? That's complicated. I need a shunt always when I need to read amps and other parameters in DC. Okay, because in the main display of the system, this display, I am reading, if you remember, how much power is entering from the shore power, how much power is entering from the solar panels. Yeah, this display will be connected with this smart shunt at the beginning. Look at the smart shunt and look at the links distributor. I'm going to put together both of them. That's the shunt, and this is, okay, I remove here. You see, and I have connection, direct connection here, positive with positive, negative with negative, no? In other words, this is a big positive bus bar, and this is a big negative bus bar. And here in the bottom, I have positives, and those positives will be connected with mega fuses. Let me explain what is the meaning of that. In the future, all the DC current in and out will be entering here or going out here between this positive and this negative. I'm going to connect mega fuses between this and this to administrate this element that is the input power for that inverter with that fuse. Other fuse here for the power coming in from the MPPT, the solar panel. Other fuse, yeah, I have fuses, doesn't matter if the DC current is entering or going out. This element is intelligent. Look at this. I have negative here, and I have positives here, and this is the output of this positive. Everybody follow me? Good? All right. Look at this. The mega fuses is to protect the current entering or the current going out. No? Those mega fuses. Mega fuses is because it's mega. The quality of those fuses. I want to show here. Come on, guys. 1 second. I have connected in series the shunt with the links distributor. That's okay? This is the link distributor. In this moment, the system is off. I am going to turn on. You see? The system turn on. And I am waiting until the display start. You see? Okay, the display is coming in. And I have a positive bus bar, and in the bottom negative bus bar. However, the positive is connected with the computer in the middle with those mega fuses. You see the mega fuses? In this particular case, I have two DC currents. One DC current coming from the MPPT, from the solar panels. And the other DC current is DC current negative and positive coming out to feed the inverter. In this moment, the inverter is working in the mode inverting, no? It's working in the mode inverting. It's providing power to the AC panel, and I have the AC panel. Okay, look at this. I have mega fuses. Doesn't matter if the current is coming in or if the current is coming out. And I have a main fuse at the beginning of the system to protect the current coming from the batteries, from the battery bank. Look, that one, you see? My battery bank, the capacity of the battery bank is two batteries, guys. It's two batteries in parallel, negative with negative, positive with positive, and I protect the positive with because the battery recommend isolator fuse, 250 amps main fuse. It's exactly the same capacity of this fuse that I am going to install here, 250 amps. You see? To protect. Okay? This is the current coming in, and I have in the positive bus bar and negative bus bar administrated two mega fuses. One current coming from the MPPT and other current coming out to this inverter charger. Pay attention. Suppose that I have a windmill. What I need to connect the windmill in the system to recharge the battery bank. The windmill produces one cable positive and one cable negative, no? Because it's an alternator with a fan, no? And produce a DC. What I need to do to install that windmill in that system.
You need an a.c.r.
Okay, you need another MPPT for that equipment. It's like an a.c.r, the MPPT. That MPPT will receive input power coming from the windmill and output power entering here. If I enter here in this position, the windmill, what I need here? Another mega fuse here. And I connect negative in the bottom. Look, negative in the bottom. And positive here, and the positive pass over there. And now I have two sources of charge. One solar panel and the second one windmill. And both of them enter in the system and recharge the battery bank here. Good? I am going, look at this. In this moment, if you see the inverter charger, all the inverters, VICTRON, they produce each of those one phase. One phase. In this moment, my AC panel is single phase. I don't have double phase. Suppose that my AC panel will be double phase. What I need? That inverter only produces one phase.
You need two inverters?
I need two inverters in tandem, like I did over there on the board. And one inverter produces phase 1 and the other one phase 2. I'm going to explain how to wire those inverters in a split phase. That's okay? In this particular case, this system is with only one inverter. It's single phase, no? Single phase inverter. Okay, it's clear the input and output DC? You don't need explain to the system that that current is in or that current is out, because the system detects if it's coming in or coming out because it's intelligent. What is the name of this one?
Smart shunt.
The shunt.